Hello, everyone, and welcome back to our series of videos, Great Ideas in Psychology. It is Tuesday, March 1st, 2022, and we have reached chapter 5 of our book, which is titled Long-Term Potentiation. This chapter is the first of two chapters that are directly about the topic of memory. I initially thought about including both chapters in a single discussion in one video, but I thought a little bit more and I decided to keep them separate, just as the author of our book decided to do that. What this idea is essentially about the neurological basis of learning, the neural or physiological basis of learning and memory. And if you say more than that, we can also say something about the scale. It is about very small scale changes that happen in the brain, in the relationship among brain cells. So imagine two cells communicating with each other through neurotransmitters, one cell sending a signal to the second neuron, second brain cell. And if they communicate with each other more, that communication is easy. It becomes easier if it happens again. They become more sensitive to each other, so that the potential for further contact between them, further signal being sent from one to the other, that line of communication, it becomes stronger. So that's kind of small scale change over time, over repetition. That is what the idea is about. But to just say that will not do justice to the importance of this idea. It will not show why long-term potentiation is included on the list of great ideas in psychology. So we have to do a little bit of work, more work, to say why it is a great idea. And hopefully we will do that in the presentation. If you're not convinced by the end, you can let me know and we will continue. We'll keep going until one of us is persuaded. One of us changes their mind. So let me begin by sharing my screen and see what I have there. So here we are. Chapter 5, Long-Term Potentiation. This is our place in the general map of the course. We are going to stay at that location for two presentations, or two lectures, if you will. So I remember watching this movie when I was much younger. The movie is called Eternal Sunshine of the Spotless Mind. It's a very emotionally charged and beautiful story. The acting is also really great. And it is, to a great extent, about memories. It is also about relationships and love. The movie tells the story of two characters who have decided to forget each other after a breakup, after a very painful breakup. And to do that, they decided to go through a procedure, medically induced forgetting, specifically forgetting certain memories. It's that aspect of it is sci-fi, but it shows the importance of memories in our psychological life, in our mental life, how memories can sometimes determine our understanding of ourselves, what we are willing to live with and what we are not willing to live with because of what we remember. Certain things become unbearable as a consequence of our remembering. And we might decide, or we might wish to forget. So the story, we encounter characters who are struggling with that. And with that struggle, they demonstrate the connection between memory, our emotional life, and incidentally, the brain, because in order to forget, they have to intervene with their brain mechanisms, brain function. So let's begin talking about memory and the nervous system. We begin with the observation that we have memories. Some of our memories are more stable than others. Some of our memories are more important than others. The question that can arise for a scientist, for a neuroscientist, or even a psychologist is, how do we form our memories? What are the underlying mechanisms, neurobiological mechanisms of memory? That is a question about not the experience of remembering or experience of memory. It is also not exclusively about the nervous system. It is about their connection. We have these two great thinkers from the history of philosophy, and they gave us two different ways of thinking about mind and matter, that relationship between mind and matter. Descartes thought about the two sides as fundamentally different. For Descartes, reality is fundamentally divided into two different kinds of things, two different realms: the mental reality and the material reality, the physical reality. For Spinoza, who I think is more aligned with our contemporary scientific thinking in that way, at least the way I'm going to formulate it now. For Spinoza, matter and mind, the mental life and the physical reality, they are two attributes of the same reality, because for Spinoza, there is only one reality. Reality consists of one kind of substance. Only one thing exists. That's, you can call that monism. And because only one thing exists, the mental reality necessarily has a corresponding physical attribute, on the side that really exists. And on the other hand, the physical side has mental attributes, corresponding mental attributes. So these are two different ways of experiencing the same fundamental reality, underlying reality. In general, we can say there are, many occasions we find ourselves expressing the same thing in different ways. There are different ways of expressing one underlying thing. So for example, I say the capital of France, or I can say the birthplace of André Gide. So these two both refer to the same city, namely Paris. Another example that is quite popular, and I don't know why people are so fond of it, in textbooks that people write, especially introductory textbooks of philosophy, is the morning star, evening star phrases that people used to think that they refer to two different things, two different stars, but later they discovered that they both refer to the same planet, not even a star, the same planet Venus. Because of the context of those observations, people felt or thought that they are talking about different things. So the same logic, you can apply it to memory. Memory itself is a psychological concept. It is experienced subjectively. You say, I remember, or I am remembering. But assuming that there is an underlying physical reality corresponding to this psychological concept or psychological activity or psychological experience, there must be a physical trace or physical traces in the body, specifically in the brain, that support or enable these activities of memory. Those physical traces, one of the advantages of finding those physical traces is that they can be studied, examined, thought about from the perspective of other people, third person, including doctors and scientists who might want to solve problems about the disorders of memories, problems with memory, like Alzheimer's, dementia. If they understand memory sufficiently from the perspective of a third person, from a scientific standpoint, objectively, they might solve some of the problems of memory. There's an assumption here. We are going a little bit back in history. An early assumption was that for every one memory, there must be one memory trace in the brain. So if I have a memory of my grandmother at my six-year-old birthday, my sixth birthday, if I remember one instance of seeing my grandmother in that one moment as I was about to blow the candles on the cake. So that is one memory, and because it's one memory, there must be, according to this assumption, there must be one trace in my brain. And if I lose that trace, that particular memory is gone. They used to give a name to this idea of single physical trace corresponding to a single memory, and that was engram. And long-term potentiation is the current word that we have that is the more evolved, more advanced version of that older concept of engram. So it's a descendant of that, even though it is different. For example, I think the most important difference is that engram referred to a thing, something that you can point to, the physical part or physical trace. But LTP, or long-term potentiation, refers to a mechanism or property, a process, not a thing. You can't point to something. As I said, you cannot point to the communication between neurons. You're not pointing to a thing. You're pointing to a process. Let's quickly go through a bunch of names. I don't really like using too many names in a presentation, but I think in this case, at least, it is unavoidable, because we are looking at how this idea of engram and memory and neurological underpinning of memory has traveled through time. So let's go through a list of names. I hope you don't mind. The first one is Franz Gall, who gave us the idea of phrenology. Phrenology, very briefly, is the idea that psychological tendencies, psychological functions are located in certain areas of the brain. And even more than that, if someone has an inclination or an ability, psychological ability, that part of their brain is larger. And the corresponding area of the skull is larger. So you can measure areas on the skull. You can measure certain identified parts of the skull that correspond to areas and psychological functions. And you can tell what inclinations, what psychological tendencies and abilities people have by measuring their skull. It's really interesting that that is a repeatable and reliable observation, but it has been refuted. Another important note we should add here is that just because phrenology has been refuted in our time, we don't believe in it anymore, but phrenology has a more, has a structure, the kind of knowledge that phrenology wants to give us. We have to also pay attention to the structure of that knowledge. How does phrenology want to structure our knowledge about the brain and about functions, mental functions, psychological tendencies, and the differences between people? That general structure is still with us. That structure is about how function is localized in parts of the brain and individual differences that we might observe. Then we have the idea of association and associationism. John Locke, the British empiricist, should probably also be included in this list. William Hamilton, I included Hamilton in the list because in my thinking, I also see him as in the associationist camp. But the person who Mohaddam mostly associated with associationism is Alexander Bain. So this is referring to the idea that when you see two things together again and again, if you see a friend carrying a purple umbrella every time you see this friend, then in your mind, that friend is going to be associated with a purple umbrella because you saw the co-occurrence of those two things. Then we get Pavlov and Sekhanov, who talked about conditioned responses. So we have these responses instinctively. We are equipped. We come to this world equipped with an ability to respond in certain ways through the bodily capacities we have. But these responses can be conditioned, can be shaped further. We can learn to respond when we encounter certain new stimuli that we were not naturally predisposed to respond to. So this is a conditioned response. It's also foundational in learning theories. And they also have that feature of being very focused on elements of learning. And of course, William James. William James talked about neuroplasticity, the association between physiological change and psychological change. And he also talked a lot about habit. His ideas on habit are still relevant and are still worth reading. I mean, Principles of Psychology, of course, is still very much worth reading, still probably among the best, if not the best textbook of psychology. So habits, changes in habit, the inertia, psychological inertia that we have, our mental associations, those correspond to an underlying physiological reality, and which is neuroplasticity, the changeability of our nervous system. So after these pioneering ideas and pioneer thinkers, we get to more contemporary people and scientists who focus on localization of mental functions. And one of the most important ones was Karl Ashley. There is this really good book by Nadine Wiedman on the life of Karl Ashley. It's called Constructing Scientific Psychology. What Karl Ashley did for the context of our discussion, what was important in his research was he had animals learn about a maze. So they learned to solve a maze, where to go, where to turn, how to find a food or a reward within a maze. And then he did surgery removing certain parts of their brain. And his question was initially about localization. He wanted to see which part of the brain does he need to remove in order to delete or erase the memory of this maze. And surprisingly, what he found and what surprised him was it doesn't matter. It didn't matter where he removed the part of the brain or where he did a cut. It was the size of the removal that mattered. The larger the size of the removal, the more animals forgot. So that was an observation that went against the assumption of localization. And he argued based on those observations, he argued that brain acts in a holistic way in its entirety. The whole brain responds, the whole brain remembers. Of course, there are contrary evidence. Every time there is one set of evidence supporting an idea, you can always find another set of data supporting the opposite idea. Here we have Wilder Penfield, who did brain stimulation on awake patients while they were when they were about to go through a surgery. So he stimulated parts of their brain, and he discovered that different parts of the brain, if you stimulate them externally, artificially, they get different perceptions or thoughts or memories. So his observations were consistent with the idea of localization. So different parts of the brain, different associations in different areas correspond to different memories or different sensations and qualities. So Ashley and Penfield are general thinkers or scientists having done work about localization and the brain basis of memory. Now we get to thinkers that are whose work more directly relates to long-term potentiation. To talk about long-term potentiation, first you need to establish that there are brain cells that are separate from each other and that they communicate with each other. That was thanks to the works of Ramon E. Cajal. So Cajal was the person who discovered that the entire brain consists of separate cells. And these cells are not touching each other. There's actually a space between them. And in this space, they communicate with each other with some chemicals, later called neurotransmitters. That was Cajal's major contribution, the discovery of neurons, separate cells. So now that we have separate cells, we can talk about communication among cells. And a big contribution, really huge advances and developments in the field of neuroscience were done by Charles Sherrington. I'm really curious about the life of this person, Sherrington. There is actually, as I was preparing this talk, I found a biography of Sherrington. I'm really interested in reading that, hopefully in the near future. So what Sherrington did was he found learning and habit at the level of neurons. So Daniel Dennett has this idea that you cannot say about neurons that they learn or they think, but you can say they sort of learn. That's why I put quotation marks around learning there, learning at the neuronal level. Let's say you have a neuron that requires a certain amount of stimulation, and below that level of stimulation, it's not going to activate. It's not going to depolarize. You stimulate this neuron, you make it activate maybe 10 times, 20 times. After all those repetitions, repeated activity, then that neuron now requires a weaker stimulation in order to become active. So now less is required to activate that same neuron that previously required a larger stimulation. This is an observation that establishes the importance of experience for the neuron. Then we have Donald Hebb. And Donald Hebb also talks about association between neurons. When a group of neurons fire together and they all activate at the same time, simultaneously together, they form the so-called Hebbian assemblies. And those assemblies are not just different things that are being activated at the same time. They are now representing or forming a single functional unit, a functional unit that corresponds to an assembly of cells. So the most important steps, conceptual steps in their early form were given by Charles Sherrington. That is essentially the main things related to long-term potentiation. But of course, Sherrington's observations were followed by more detailed, filling the gaps and details in knowledge. We had what the chemicals actually are, NMDA, non-NMDA activation. And then we also had the addition to LTP, we also had LTD, long-term depression, which is related to inhibition of a neuron by another neuron. One of the things we read in our book about some of the limitations of LTP as an idea, some of the things that it cannot explain, and we consider whether it is reductionistic and why it could be a reductionistic idea. That's more raised as a question for us to think about. We also consider the idea that it doesn't necessarily explain or describe higher level psychological functions and higher forms of memory. For example, our memories are not just about associating things with each other, simple things with each other. We also learn schemas. We learn about schemas like going to a restaurant, playing tennis, giving a lecture, listening to a lecture. In the textbook, in our textbook, we also read about values and how there was a person recently discussed why LTP is not adequate for explaining value learning the value of different objects and stimuli, and the difference between higher order and lower order intentions, goals, and values. That's also difficult to explain based on a mechanism that describes communication among neurons. So we need to get more specific about brain areas and what makes LTP in different brain areas different from each other. This is an article that I like, published by Lane and colleagues in 2015. It talks about, it's really interesting connection between LTP, consolidation of memories, and reconsolidation, the reconsolidation window. So the process of remembering a memory, remembering something, an episode or a kind of episode, that is a process that not only allows us to remember, but also it's a process that makes memories vulnerable. It is through remembering and repeating that you can have a chance to change a pattern of feeling and behaving and responding. This connects to the psychoanalytic discussions and problems that psychoanalysis identified about getting into a pattern and repeating unhelpful and destructive patterns of feeling and behaving without being aware that we are repeating. This article is important if you have interest in psychoanalysis and neuroscience. And it explains, incidentally, why in the movie Eternal Sunshine of the Spotless Mind, why these characters have to remember the thing while the memory is being erased. Why is it that every time they have to live through those memories? Why that memory has to be activated before it is forgotten? So by learning about reconsolidation of memory, that's a nice connection. We can think with that. These are two books. The book on the left side, the Neurobiology of Learning and Memory. This is the edition that I read when I took a course on neurobiology of learning and memory with Hugo Lehmann, my old professor. I believe there are two later editions of this book came. This is really a nice book, especially if you have ambitions and aspirations in neuroscience, if you'd like to become a neuroscience graduate student. This is a nice, readable, very accessible, readable book for beginners in neuroscience, especially. On the right side, we have a book by Eric Kandel, which is a kind of autobiography mixed with his research, his own research in neuroscience of memory. And Eric Kandel, we read in our book, is one of the people who also founded a pharmaceutical company named Pharmaceutical Learning, something like that, or Memory Pharmaceutical. Maybe that's closer to the actual name. But the intention behind that was to use these scientific insights, these observations, the findings, to combat and maybe provide cures for disorders like Alzheimer. All right, this is the end of our present presentation. Next time, we are going to talk about chapter 6, learning. If you enjoyed this series, if you would like me to continue, please press the like button to support the channel and that against the YouTube algorithm. Please comment if you have any questions. And if you would like to support the channel, support my life as an independent scholar outside of academia, please consider signing up on Patreon as well. If you are interested, I just invite you to do so. All right, that's all for today. Thank you for watching, and till next time.